Okay, Pute. Now, today we are starting with integration of this part of it here. Just 1 second. Yes, okay. Today our session is to learn about the integration format of like this. Suppose that if you want to integrate uh, this of it, fx, and at top the differentiation of that is available here with some kind of a constant, some constant time of integration of this one at the top. How are we supposed to do this kind of situations with it? So the answer for this one become, you can say k times of integration of some kind of a function and its differentiation at the top with it, right? So your answer become finally k ln fx. From a question, let's try to understand how it comes with it. Later on, with the next example, let's try to understand how does it happens with it, right? Yes. Then, if you start some kind of a question, let's see how to get that fact. Suppose that if you want to integrate x squared plus 1 into 2x dx. In this kind of situation, now go ahead with the denominator. If there's a fraction, first, if you have a denominator, see whether the differentiation of this is available in the numerator. Yes, what is the differentiation of x squared plus 1? That is 2x. They are the straightforward, you have this differentiation. So with that you can say answer is ln x squared plus 1. Usually we put a modulus mark over here to represent, because we know that there is no ln values for negative. There is no ln value for negative. That is why we just put a modulus over here. I'll do the next extension for this. Suppose that this function is like this way around with it. 4x over x squared plus 1 dx. In this situation, what you can do? So you can see the term should be 2x. So this answer, what I can write? This one you can say 2 into 2x times of x squared plus 1. So from here I can take 2 out and you can write this one. 2x over x squared plus 1. So your final answer become 2 ln x squared plus 1 plus c is the final answer for this. That is the answer for this question. Right. If it's just like this, then this is 3x over
Sir,
x squared. Yeah, just tell me what is it, Kelly? Yes, well. Okay, right.
sir, in the
So
first one now, what happened?
is the first one? What is it?
What happened to the numerator? 2x.
That's what I mean today. The formula is if there is a function and its differentiation at the top with some kind of a constant outside, you can write the answer as k ln fx. Wait, I'll tell you what is the base for this. Just give me 1 second. Right? 1 second. Then if it is so, the requirement is we need what is the differentiation of x squared plus 1? That is 2x. So we want to make 2x over here. I'll just put 3 out and I just put x over x squared plus 1. Then now what we need is I need to make 2. So I'll just put 2 here, and to correct it I'll put a 2 at the bottom. That's the technique we use with it. Initially take that constant out, then you can put that constant and make it into correction. Then you can write the final answer as 3 over 2 ln x squared plus 1 plus c is the final answer for this. That's the way of getting this right. Now, Oshadi, the question what you ask is what happened to this numerator? 1 second. We'll go ahead with this. Okay, right. Now, the logic is this. Suppose that if you want to differentiate, ln x squared plus 1. What is the differentiation of ln? That is 1 over x squared plus 1 into differentiation of this 2x. Your final answer is how much? 2x x squared plus 1. Here the ln comes with denominator and its differentiation of the numerator. Therefore, you can write d by dx of ln x squared plus 1 is equals to 2x over x squared plus 1. Is that clear, Pratik? Right. Then, if you integrate both sides, what do you get, Pratik? This differentiation integration get cancels. This turn up into integration of 2x over x squared plus 1 is equal to ln x squared plus 1. Is that clear, Pratik? Now, what happened to this numerator? Because you know that at the differentiation, this numerator comes as excess form, right? So this one, because you know that if you differentiate ln, this is the answer. 2x there came as the differentiation of this partial. That is why we used to write the formula. If there is a function and its differentiation at the top, there with that straightforward you can write this fact as your final integration. That is the answer for your question. Is that clear, Oshadi?
Yes, sir.
Yes, right. Then you will understand what I am discussing about. 1 second. Right. So you have this kind of thing. This is you get another equation maybe x squared plus 3x plus 7. Right. Now we can go ahead with this. Now see whether the differentiation of the denominator. What is the differentiation of this? X squared plus 3x plus 7. 2x plus 3. It's exactly available over here. There with that you can say answer is ln x squared plus 3x plus 7 plus c. What happened to this one, Pratik? Because this part came as a differentiation of ln of this function. No need of worrying about this part. Only thing is that when you happen to do this, you have to see whether the differentiation of this one or it's a constant available in the numerator. That's a requirement. Other than that, at the integration, that is not involved with your final answer. You get 5x to the power 3 plus 6x. Okay. Now what you can say to this? Now see whether it's a fraction. If there is a fraction, see whether the differentiation or its constant available in the numerator. Just check whether what is the differentiation of 5x cubed plus 6x? That is 15x squared plus 6. So straightforward, that is there. So you can say this is ln 5x cubed plus 6x plus c. The use of having a modulus is we don't have the negative ones, ln values for negative. That is why we use right like this. Right. Then x squared plus 2x plus 1. X plus 1. Right. Okay. Then what you can get here today. Now see whether there's a fraction. If there's a fraction, see whether the denominator, the differentiation of the denominator, it's available in the numerator. What is the differentiation of the denominator? This is 2x plus 2 today. But what is available in the numerator? The facts available in the numerator is x plus 1, but not 2x plus 1. 2x plus 2. So, is there any way I can make them into this? So, what you can get here is the differentiation is not available. Therefore, I'll just use a technique like this. X plus 1 over x squared plus 2x plus 1. I need to make 2x and 2 today. Therefore, I just multiply everything with 2. To correct it, I can put half at outside from this integration. Now, this comes as a final answer. What is it today? 1 over 2 ln x squared plus 2x plus 1 plus is the final answer for this. That is how you need to do it. Right. Then the next part of it. E to the power 2x plus 3. E to the power 2x, right? Dx. Now see whether what is the differentiation of e to the power 2x plus 3. I just make 3x. Right, okay. What can you do? See whether what is the differentiation of e to the power 3x plus 3. The differentiation is how much? 3e to the power 3x. Differentiation of 3x plus 3 is 3e to the power 3x. Then what can we do? I can just do a technique like this. E to the power 3x plus 3 e to the power 3x. Then I'll just put like this. I need to make 3 here. To correct it, I can put 1 over 3 outside. Then you can write final answer. What is it? 1 over 3 ln e to the power 3x plus 3. Plus is the final answer for this. Now we are moving to the next important part. If the denominator, like with this kind of situation, you can do it, right? Let's go ahead with another example. So then now after doing all these theory sections and this work, you have to work by yourself this exercise and do it, because it's a kind request for you all. Unless you try these questions at home and try to sort it out, you won't be able to get a very good result. So therefore you need to work hard on these questions. Right. The next theory, just like this. Then this is cos 2x plus 1 sine 2x. Right, sorry, 3 sine 2x. Now I need to make the integral differentiation. So what is the differentiation of cos 2x plus 1? Cos 2x plus differentiation is minus 1 over 2. Minus 2 sine 2x. I need to make minus 2 in the denominator, in the numerator. So I'll just use a small technique like this. Initially, I will take 3 out. Then sine 2x cos 2x plus 1. Then I'll put a minus 2 over here. To correct it, I will divide by minus 2. Then the differentiation of the denominator is available in the numerator. So answer is minus 3 over 2 ln cos 2x plus 1 plus C is the final answer for this. Is that clear, children? Yeah, that's how it comes. Right. Then the next part of it. Just like this. Integration of x squared plus 4x minus, that is x plus 6. Now the differentiation of x squared plus 4x minus 1 is 2x plus 4. Now you can understand that by multiplying a single figure, the denominator you cannot convert into 2x plus 4. If you make them into 2, what you need to do? You have to multiply by 2. But if you multiply by 2, this becomes 2x plus 12. So therefore, it won't come as a answer. So in this kind of situations, you cannot use this formula. There is another techniques we use, that is later on we learn, that is called the integration by substitution. Sort of it, you can get this answer, right? Later on we learn how to do it in our CO4 mathematics, right? So therefore we cannot do this differentiation, because here the differentiation you cannot form in the numerator by at least by multiplying by a single constant. So in that situations we cannot do, right? We are learning how to do these integrations later, right? Then let's come up to the next formula. That is this. If you integrate fx to the power n and outside its differentiation is there. Answer is same technique. You can write this is fx to the power n plus 1 over n plus 1. In that case, the same technique, this f dash x part is ignored in the calculation because when you do the differentiation, it is coming as a sub differentiation. So therefore, no need of worrying about that part of it. Let's go ahead with one question and let's try to understand how it comes and then how to work out this kind of a sum. Right. Suppose that you have this kind of a question. You have x squared plus 3 to the power 4 times of 2x dx. Sometimes this 2x can be remain outside. Not outside, sorry, before the power term. Now see whether this is a power term, the term with the power. What is the differentiation of x squared plus 3? Differentiation of x squared plus 3 is 2x. So simply you can write this answer x squared plus 3 to the power 4 plus 1 over 4 plus 1. That is x squared plus 3 to the power 5 over 5 plus c is the answer for this. Right. Let's go ahead with another example. May come if it is somewhere like this. 2x x squared plus 3 to the power not 2x. 6x to the power 4 dx. Then what happened here? We know that the difference, this is a power term. Differentiation of x squared plus 3 is how much? 2x. But here the remaining term is 3x. Sorry, 6x. Therefore, I just put 3 here and I will write 2x times of x squared plus 3 to the power 4. So this term is 3 times of x squared plus 3 to the power 5 over 5 plus c. So answer is 3 x squared plus 3 to the power 5 over 5 plus c is the final answer for this. That's a way of getting this answer. Right. Let's go ahead with another question. For example, you have another question. You get the integration of sine to the power 4x cos x. This dot means multiplication. Now it's a power term. The simple notation for this is sine x whole thing to the power 4 times of cos x. So what happened to this answer? Sine to the power 4 means, so differentiation of sine x. What is the differentiation of sine x? Differentiation of sine x is cos x. So it's over here. So you can say this is sine 5x, sine to the power 5x over 5. Plus is the final answer for this. Right. Right. Then let's go ahead with another example and see whether. So you get this answer this way. Tan to the power 4, sorry, tan to the power 6x sec squared x. Right. Now there are powers in the both terms. Now initially we will consider this is the power term and see whether the differentiation of that is available here. I just consider like this. Tan 6x, sorry, tan x to the power 6 times of sec squared x. Now what is the differentiation of tan x? Differentiation of tan x is simply we know that is sec squared x. So with that you can say this is tan 7x over 7 plus c is the final answer for this. That's a way of getting this, right? Let's go ahead with another example. Tan x sec මෙන්න මේක with a little bit of important 6x. Then what can you say? Now this is a power term today. What is the differentiation of sec x? So then make අපිට ගන්න වෙන්නේ කොහොමද? We have to take it in this way. Tan x times of sec x whole thing to the power 6. What is the differentiation of sec x today? Can you remember? Oshadi, what is the differentiation of sec x?
So sec x tan x, no?
Yeah, okay. Madhushani? Yeah,
Sec x tan x.
මෙතනින් අපිට එතකොට we have to isolate one sec x tan x. එතන මම මෙහෙම කරන්නම් මේක. Tan x sec x කියලා මෙතනින් අපිට I'll just take one sec x out. So it is turn up to sec x to the power 5. Then now you can see here the differentiation is available in this term. So with that you can say this is sec x to the power 5 plus 1 is 6 over 6. Plus is the final answer for this. That's a way of doing this kind of a question, right? Right. Similarly, is that clear? Right, hopefully. Then we use the same technique to do this kind of questions as well. Maybe just like this. This is the last part of this topic. Integration of this is x squared plus 4 to the power 3, 2x plus, sorry, 2x. Then in this case, you cannot use ln. Why we cannot use ln? There is a power in the denominator. For the numerator expression, it has a some kind of not a power 1. So you can apply this format. Then you can say x plus 4 over 2x. Straightforward, you can use the ln function for that. But this is not power 1. The total power is not 1, but its power is 3. In this situation, we just use the same technique we usually in this example today. I'll write this answer as x plus 4 to the power minus 3 times of 2x. I can say like this. Then you can use the usual fx to the power n format of the answer today. So how can you do this? It is x squared plus 3 to the power minus 3 plus 1 over minus 3 plus 1 plus c. That is x squared plus 3 to the power minus 1 over minus 1. So you can take this minus 1 over x squared plus 3 to the power.
So it's minus 2, no?
Minus 2. Sorry, I just made a mistake. Minus 2. It's not minus 2. Minus 2. So it's 2 and this is 2. 1 over 2. That's how it comes. Right. Let's go ahead and example. Integration of sine cube theta cos theta d theta. Then what happens? So here you can say ln because it's not power 1, power 3. Therefore, I just write this is sine power 4 sine theta to the power minus 4 times of cos theta. Then the differentiation is here, so you can say sine theta to the power minus 4 plus 1 is minus 3 over minus 3 plus c. So answer is minus 1 over 3 times of sine cube theta. Plus is the final answer for this. That's a way of doing this kind of a question, right? Yes. Today, when you launch it the video, you can get them, right? It's not a problem. Hopefully. Children?
Yes, sir, can get.
Can get, not a problem, right? Okay. Then we can so you get equations and well like this one. Tan 3 theta tan 4 3 theta sec squared 3 theta, right? Then how do you supposed to do this? You can take, this is tan 3 theta to the power 4 time of sec squared 3 theta. The differentiation of tan 3 theta is how much? That is, if you differentiate this answer is sec squared 3 theta into 3. But here there is no 3 over here. Then what can you do? You can put a 3 here. And you can put a correction 1 over 3 outside from this integration. That's the technique we use. With that you can say this is 1 over 3 tan, sorry, this is minus 4. Tan 3 theta to the power minus 4 plus 1 is minus 3 over minus 3. So answer is minus 1 over 9 tan 3 theta to the power 3. Plus is the final answer for this. Okay, that is a way of doing this question. Right. Our question. Yes. Dx. So you can understand that here this is 2x squared plus 1 to the power half times of 6x. The differentiation 2x squared plus 1 is 4x. I want to make 4x over here. How do you make 4x? Initially, I just take 6 out. 2x squared plus 1 to the power half. Then this is turned up to x. Now I want to make it into 4. You can put here and put a 4 down. Then that's a way of doing this. So the answer is 6 over 4. Sorry, I think it's not clear. Now, initially I just take 6 out. Then after that, I just can put I just put 6 out. Then you have to make 4x. So I just put 4 here. And to correct it, I can put a division 4 here. That's a way of getting this right. Okay, then what can you do? Then you can say 6 over 4 is 3 over 2x squared plus 1 to the power half plus 1 is 3 over 2 over 3 over 2 plus c. This is 3 over 2, 2x squared plus 1 to the power 3 over 2. These 2 remain over here and 3. Sorry, these 3 remain over here and 2 comes at top. So this 3 get cancelled with this 3 and this 2 get cancelled with this 2. Final answer is 2x squared plus 1 to the power 3 over 2 plus is the final answer for this. Right. That's a way of doing this kind of a question. Right.